In this video, I want to talk about the point replicate node. This node essentially creates a certain number of points per point. And at first, that doesn't seem like a very interesting thing. But if you're creative with how you use it, this node can actually accomplish a lot of interesting things. I'm going to give you two examples of how you can use this node in this video. But do keep in mind that there's other ways to creatively use this, and that's part of how this node is actually kind of fun once you start imagining the different ways that it can be used. Before we get going though, if you enjoy this video, then be sure to check out the Node Bible at CG Forge. I'm only going to keep this video on YouTube for the next 2 weeks. Then I'm taking it offline, and the only place you'll find it is going to be at the Node Bible once it's off YouTube. Let's start off with the basics though, shall we? Let's say that I have 50 points. I plug this in. The points per points is 100. Now keep that in mind because that default right there could crash your computer if you plug this into something with millions of points. So my recommendation right off the bat with this node is to change the defaults here so that you don't accidentally crash your scene if you're working with lots of points. Set this to 1 and then go to the cogwheel. I believe it's under legacy presets now, and you say save as permanent defaults. Now, anytime you make this node, the point replicates, and you're not thinking and you plug this into something with 10 million points, it doesn't accidentally crash your scene. So that's step number 1 with this guy. But let's say that I turn this up, right? We have lots of points now. The shape is the next thing you want to start thinking about. This essentially takes the original location of the point and it randomly moves away from that location based on some kind of shape. So the shape right here by default is box. We can see this gives us a very, well, boxy distribution of points, but you can change that to a variety of different modes. So I could say sphere, I could say cylinder. Let's go over this stuff in a bit more detail later on. But for right now, just keep in mind that you pick these different shapes and the new points take on that different shape. Once these new points are offset based on the shape, you can then further add detail by optionally adding a noise. And that further randomizes the shape beyond what the original distribution is. So it starts by taking the shape and then the noise gets applied. And with this, we can change things like the amplitude, right? You have all your normal noise features that you're used to having. Also on the amplitude, you can overdrive this. And so I can take this and drive it even further. Just keep in mind that this amplitude's also going to listen to the shape amplitude. So in other words, if I turn the shape down to 0, we have our original points. But no matter what I do to the amplitude of our noise, nothing happens. So think of this noise as taking its amplitude as a portion of how much we affected this original shape parameter right here. That might be a decent way of thinking about this. And then this last tab here is the attribute section. So if I have any incoming point attributes, don't forget to say copy source attributes. That'll take the additional spawn points and they will inherit whatever original attributes were there on the point that it came from. So there's this. There's a few other options with velocity that we'll talk about in a bit. And in general, that's what you're looking at with this node. Now, as I said before, where it gets interesting is when you start getting creative with this whole process. So now I want to switch gears and show you the kinds of things you can do with this node. And starting here with this bubble situation. Let's say that you have some kind of water, some sort of fluid, and you want bubbles lying on top. Well, bubbles are often just multiple spheres that are right next to each other, right? So what I have going on here is I have an initial scattering of points, and then I create a random number of additional points per point that are close by. And so what happens here is I do the point replicate, and we can see that these little clusters of points have begun to happen. And as I take our scale from 0 to about 2.5, we can see that this all happens in a localized area, which is what foam, or which is what these bubbles would naturally do. So because of that, we have a nice distribution of bubbles because points came from points. I then use the ray to bring them back to the surface so that they're all along there. And then we do the remesh bubbles node here to generate these spheres. And as they overlap, we can see that there's nice little clusters of bubbles that begin to appear. Another interesting example is when we try to source pyro. It's very, very common for, let's say, pyro to just come from a sphere, right? You have a sphere, we then turn that into a volume, we can scatter some points and then rasterize those points into source volumes for whatever it may be. So just having a solid object, doing a VDB from polygons or making points and rasterizing them, that's just a very standard workflow when it comes to sourcing pyro. But the point replicate could allow you to have a more interesting source that isn't as commonly found or used. And that can make your pyro look a little bit different than what people are used to seeing. Let me show you what that looks like here. Suppose that I start with a box and I scatter some points, and I have 1,000 points along this box. Well, when I start here, I can then, let's say, create a random point velocity. So I have velocity moving in all sorts of different directions, and then on the point replicate, I'm going to use that velocity to stretch out the distribution, to stretch out the shape that these new points are going to have. So here on the point replicate, this creates a huge mess, but what's interesting is that now I have these little doodles that I can make. So when the shape here is line, and let's say that I'm stretching this based on velocity with this parameter, I can, let's say, take that velocity, make these line shapes, and then stretch everything along those vectors. So this creates a very interesting, unique pattern, almost like a little sparkler looking effect, right? in the source. All of that goes to rasterize here into volumes. And then over time, this is going to switch up its shape every single frame, and that's going to give us an interesting pyro source. Allow me to show you a few different play blasts of what it's like when our smoke doesn't have any variation. So when we have this kind of shape, and then I'll show you another play blast of what it's like when we're switching it up with that kind of source shape. Here is 90 frames of no breakup, just a spherical source within a pyrosim. This is the point replicate method that we just did with our source. And then just for fun, this is what it looks like when we have the point replicate method, and I've added in other microsolvers like disturbance and turbulence. The moral of the story is that the point replicate can be responsible for a lot of interesting effects if you're creative in how you use it. Now let's go through each of the parameters step by step. I'll talk about what everything does, and then once you have this knowledge, it's up to you to apply it in some kind of creative way. Starting at the top here, we have our group. So if I only want to do this on certain points, I can click that arrow, highlight that, and it isolates the effect. This node will also remove the original geometry and spawn new points in place of that. So if you don't want to remove the original geometry, then just turn on Keep Input Geometry. It won't be visually different because the first point it spawns is at the same location as the original geometry. But just in case, for whatever reason, you don't want it removing everything and then spawning points, then Just, keep in mind that that option is right there. Here's the points per point. That's exactly what it sounds like. But more interestingly, we have this generate from attributes. And this allows us to randomize the number of points per point. So in the foam or the bubble example that I was showing you earlier, what I did here is I created this attribute called rand points rep. So random points replication is what I was thinking in my head. That attribute is a random value between 0 and 1, and that multiplies against the integer value of 5. So you give each point a random value on the attribute, that value multiplies against this, and that allows you to randomize the points per point. Moving on to the shape tab, most of these shapes are self-explanatory. The only ones that are a little bit weird are towards the bottom. That's going to be with the point, the file, and the SOP. But let's just run through them so you can see it. This is box, sphere, cylinder, as you might expect, cone, grid, circle, and line. Now, the interesting thing about the line and some of these other ones like the cone is that this is going to pay attention to your normal attributes. So up here on the scatter, I have normals. If for whatever reason I was to change that, that would change the orientation of these cones or the lines or anything that's going to be direction oriented. As an example, I'm going to create the poly frame node, and I'm going to just switch up our normals here so that before we scatter, the new normal is going to be tangent like that. And as you can see already, this is before and after. If you change the direction of the normal, so too does the orientation change as well. Just so that we can see where these normals are pointing, let's take a look at these points. So let's take a look at this guy as an example. He's pointing that way, and then when a cone gets generated, the tip of the cone goes away from that normal, and the base is heading in the direction of that normal. Also keep in mind that the line option is going to be perpendicular to the normal. So we can see that right here. This is the original point number. The line will be perpendicular. The point method is going to create a point a specific distance away from the original point. So you might think, okay, the normals are going that way. So if I take the y direction, well, the y is actually going to be perpendicular to the normal, and the z direction is going to head in the direction of that normal. So just keep that in mind as well. The normals indicate z, not y. And yeah, there you go. If you have any other orientation attributes on the points, this should listen to those orientation attributes. But for most situations, you just have a normal, and then keep in mind that this will be z, and then y will be perpendicular, and, well, you get the idea. Also keep in mind that the point mode will create overlapping points. This is an absolute value for all spawned points. So if I create 345 points, they are all stacked on top of each other right here. That brings us to the last mode, and that is either the file or the SOP. And to demonstrate this, we're going to do SOPs, and would you look at that? I think I spy a pig head. This allows you to take geometry and turn it into the shape. So you can either browse for a SOP that's in your network, or you can load a bgeo file with this file option, and that will be your custom pig head shape or whatever suits your fancy. The other parameters are fairly self-explanatory. The center here is going to create an offset from the points. So if you want them moving, offset like that from the original point, you can do that. You can stretch them like this. And then also you can stretch them using velocity. That's what I did with our pyro sourcing. As an example, I'm going to create a point velocity node. So there's point velocity. Create a curl noise right here, so that our original points now have velocity. Then I go here, and I can use this velocity stretch to really stretch them out. So let's just take a sphere as an example to give us a good example of that. There is something fairly annoying about this though, and that's the fact that the velocity stretch often happens perpendicular to the velocity direction. So if, for instance, I go here to our velocity trail, that's right here, this lets us know what direction velocity is heading in. You would think it stretches in, this direction right here, but when we actually go to stretch that velocity, it doesn't really do that. So if you're having a hard time controlling that velocity stretch, there's a nice, simple little hack I have for this using the scatter align node. Go ahead and set that down, and I'll plug both in here. Go to the top, set the mode to add attributes to existing point cloud. Then go to the attributes tab down here, turn off orient, and then we want to go down to the blend normal width attributes, set that to velocity, and then set that to 1. So now if we take a look at our points, there's our velocity trail, and as you might expect, that is the direction that everything stretches in. Don't worry too much about this velocity stretch of scaled versus ignore geometry scale. Basically put, keep it at scaled, and this will be simple for you. If you say ignore geometry scale, then it just treats this velocity scale a bit differently. You might need lower values as an example. And the other thing that you might want to keep in mind is that p-scale, if it's sourced in to the point replicate, will change the look of this a bit as well. So if I delete p-scale and I take down my uniform scale here, now everything's a lot more even than it was before. So as you're making these velocity effects, I would suggest turning off p-scale or not sourcing it in, and then also, just taking velocity and making everything work like this. Another thing to keep track of is the magnitude of your velocity vector. What I mean by that is certain points are going faster than others, depending on how far away that velocity value is from the original points. In plain English, what that means is that some of the points are faster, which is why they're stretching more. If you want to make everything the same speed or have the same magnitude in the velocity vector, then before you go to the scatter line, write out this little bit of vex. We just use the normalize function right there, and what that does is it takes the magnitude and sets it to 1 away from the point. So now everything is 1 meter away from the original point, and the only thing the velocity really describes now is the direction. So by doing that, now when we go to our velocity and we turn up the scale, they all scale evenly, like so. And since we're getting all fancy and technical now, we also have this quasi-stratified sampling, which obviously means that the points are going to be distributed slightly differently if you turn it off. Leave this on unless performance is becoming a problem for you. Most of the time you can leave this on and it basically takes the points and fits the shape better by using a different algorithm. And if you turn this off, it's a little bit faster, but a little less good at filling up the shape. Next up is the noise tab. And there's a couple of quirks to this noise tab that you need to keep track of. For one, when we have the velocity stretching right here and we overdrive the amplitude, it will continue going in that direction. So one way that you might want to spice this up a little bit is by taking the velocity scale down like this, and maybe we can even take the scale down here as well, so that we don't have a whole lot, but we have that velocity direction. And then as I turn up the noise, we just have a slightly more interesting shape that unfolds because we now have all these parameters with the roughness, like that, and with everything else. So the way that I like working with the noise is kind of like that. It's a nice way to break up the shape so that it's not just obviously a cylinder or obviously a square or a cube or whatever. So whenever you're looking to jazz things up, use this noise section, but be aware that this relies on what you did in the shape tab, and it will generally follow whatever you set right here. If you want different shapes, the noise type will give you that. Frequency is the size of the details. Offset will give you a different version of this, essentially, by offsetting the noise. Amplitude is how much of it you want. Roughness is how many tiny details you want. The higher it goes, the more tiny details. The lower it goes, the more it smooths. Attenuation is something I don't recommend playing with, so just leave that alone if you don't know what that is. And then turbulence is going to just add a little bit of extra roughness, essentially, a little bit of fine detail as you turn it up. But I generally recommend keeping turbulence at the defaults or somewhere around a value of 1 to 5. The lower your frequency value gets, the more turbulence you need in order to capture those tiny details. So just the only time I mess with this is if the frequency is at a low value. I might turn it up 1 notch like that. Otherwise, most of the time you don't need to play with it. The last tab here is the attributes tab. And as it sounds, it's all things attributes. Copy source attributes takes all the original attributes that were on the point and applies them to all the spawn points. So a lot of times if you have color or mass or other different things that for whatever reason need to be on these spawned points, check that on. And if you want to be more specific about the attributes, by default it should be star, so that means just take everything. But you don't have to do that. You can say which ones you want by doing this kind of thing. So let's say I just wanted color and velocity. I would type it out like that, and that would preserve velocity. And if I had color here, like this, it would also take that along for the ride as well. Inherit velocity. Well, inherits the velocity. What that means is that it just takes the velocity value that was on the original point, and you can exaggerate that or bring this down like so. What's more interesting is this radial velocity. Check this out. As I turn that up, it's almost like we have a nice little curvature that begins to happen along these motion blur arcs. And when you go to do motion blur, if it's velocity based, having that curvature there is really nice. It adds a lot of detail oftentimes. And so usually with this radial velocity, what I'll do is start here at 0, and then I'll find an area that is really blurred out. I mean, these are all blurred out by velocity. And then I'll just turn it up ever so slightly, kind of like that, and just add a teeny bit of it in there to break up those vectors. Don't worry about this attributes to transform. It's a legacy parameter. It's not really relevant anymore. Keep source attributes adds 2 more attributes to the points here, and this actually can be very useful. The source point stores the ID of the original points that something spawned from. So if we want to see that data, as an example, I'll just go ahead and turn on this visualization. And if we take a look at, let's say, this motion blur arc, they all came from what was originally point number 97. So that lets me know where these guys came from. Also, if we want to turn that off and check out the source ID, what that does is it counts up from 1 to however many points are spawned per area that something spawned. So in other words, we have this whole motion blur chunk, right? When it spawns points, it's going to start at 1, then go 2. Well, it'll probably start at 0 actually, and then go 1, 2, 3, and so on, all the way up to the maximum number of points. So it's a way of just categorizing the spawn points and saying that this was the first one to spawn or this one was the last one to spawn. That's a good way of thinking about it. Also, what's very useful is this create output group. So if you just want to group the spawned points, then I could say spawn points, and now I have a point group right here that only selects the new points. That might be really useful if you're trying to spawn points from spawned points, and you're trying to not affect the original points or something like that. So perhaps as an example, if we had our bubble foam situation, each time I run the point replicate, I want the p scale to get lower and lower and lower. Well, each time I run the point replicate, because I have these groups, I can use the group to scale down p scale every single time this gets used. So that could be just one example off the top of my head of how you might want to use these groups. And if you did that, then, well, this whole section would be very handy. One more thing I want to mention about this node before we wrap things up. When you have a particle simulation, you can use this with pop sims to add more points after they've been simulated. So as an example, I have these particles, right? I can do the point replicate afterwards, and look at this. We have little clusters of points that are stable all throughout things spawning. And this might be really useful in a situation where you need millions and millions of points, but you don't want to simulate millions of points. Sometimes, not always, but sometimes you can get away with doing this point replicate and then doing some other things to break things up. I don't always recommend going this route sometimes because it can look like you did a point replicate easily if you're not careful. So make sure that you break things up as much as you can if you're using the point replicate like this. But I just want to let you know that a lot of people use this in particle simulations. And in order for that to work, make sure that you go to the documentation and check out the first thing it says here at the top, where it says that you need to ensure that you have ID. And if you have the rest attributes, then that might be a useful thing as well if you want to use the noise section. So as an example, if I add a noise here and this all goes up, sometimes that noise will kind of, distort things as it moves through space. So I'll try to get it to really act up here real quick. So if I take the amplitude up to 5 as an example, and I take the frequency down or up to something like that, as these points move through space, you could see that they're really jittery. So what you can do to fix that is use a rest attribute so that when the points move through space, the noise values are not changing on this noise tab. Go to the popnet. I'm going to make a just born group called just born so that as particles spawn, the ones that are just born are grouped right here. Then I'll create a point wrangle, and all I'll say is that our rest attribute is equal to the current position, and this only affects points that are just born. So it stores rest once, and then after that, the rest value doesn't change, and because of that, the noise coordinates are also not going to change. So now, as I go through here, we can see that we've stabilized the vast majority of the simulation. And there you have it. That does it for the point replicate node.